Okay, so let's consider this integral here, integral dx over x, square root of 4x plus 1. Um, this really doesn't fit anything that we've learned. We might make some attempt with maybe an integration by parts idea, thinking maybe that's somehow a part of it, something to do with maybe integration by parts. Maybe that somehow has some bearing on the problem. We're really not sure, right? We could kind of fumble around and try some things, maybe try a substitution and try to rearrange things to maybe get into the format of something we might be able to work out. Okay. But the main point here is this is something that we just don't really recognize. Okay. So let's turn to our integration table. Our problem was 1 over x square root of something. So we're looking for something that maybe matches with that. So I look at my formulas here. These are trig formulas. These are integrals involving a squared minus x squared minus a squared. None of those qualify. A squared plus x squared. Okay, now we have integrals involving some linear factor of ax plus b. So we start looking through those because we have a 4x plus 1 that does fit that format. So you might notice here as you look through, here we have x square root of ax minus b. Here we finally have the one we want. X square root of ax plus b. Dx over x square root of ax plus b. That's actually the formula we're looking for, number 89 there. So let's copy that formula down here. The integral of dx over x square root of ax plus b is equal to, it says 1 over square root of b ln absolute value of the square root of ax plus b minus the square root of b over the square root of ax plus b plus the square root of b plus a constant. So looking at formula 89 there, and we notice that our integral fits that format. As exactly how they got this, again, I'm not 100% certain even on my own of how to integrate something like this right off the bat. But I can see where the 1 over square root of b came from. They actually divide all this stuff by b. Factor out the b, so you'd have a over bx plus 1, and then square root of b would come out, and so that's sitting out front. And then that's where that part came from, at least. How the rest of this pieced together, well, I'm not 100% sure. You could try differentiating this function and maybe seeing how that led back to this. But we're just going to focus on only using the formula. Okay? A lot of these formulas have been generated through maybe some complicated techniques, maybe even sometimes aided with a computer to come up with the formula. Okay, so we're just going to be using it. Okay, so we have the integral of dx over x square root of 4x plus 1. So in our formula, recognize that a is 4 and b is 1. And then we just use our formula. So our integral of dx over x square root of ax plus b, or not ax plus b, sorry, it's 4x plus 1 would be 1 over the square root of b. b is 1, so that would just be 1, times the ln, absolute value of the square root of ax plus b, so square root of 4x plus 1 minus the square root of b, all over the square root of 4x plus 1 plus 1. All that inside the absolute value. And again, you could, on your own, differentiate this log function to see that its derivative should become this thing. Okay, so we're just going to leave it at that. And there's our answer using this integration table. Now, sometimes what you'll need to do, and we'll see that in the next example, is you do need to maybe adjust your integral so it fits the integration formula. You may need to do some things like factoring out or something like that to work out the integral. In these first two examples, that wasn't the case. Everything, you just kind of recognize the parts and carry it through. But in the next example, we're going to see where we do have to sometimes do a little manipulating of our integral to make it fit the format of the integral formula that we have.